Our warm-up today, we're reviewing what we learned before Thanksgiving break. So make sure you've done your work and are ready to go. These problems are both set up for elimination. Remember, there are 3 ways to solve: graphing, substitution, and elimination. Number 1, you could solve by substitution if you prefer that, because this y is pretty close to being by itself. But since the x's and the y's are lined up, elimination will be better. And if you notice, the y's are already opposites, so I can go ahead and directly add these 2 equations together. 3x plus 2x makes 5x. My y's cancel. 6 plus negative 1 is 5. To solve for x, we then divide both sides by 5. So x equals 1. So now we need to find what y is, plug it back into either equation. I'm going to choose the bottom one because the y is positive, so I'd rather solve for a positive y than a negative y. So we have 2x, but that means 2 times 1, since that's what x is, plus y equals negative 1. 2 times 1, well, that's of course 2. Subtract 2. So y equals negative 3. So my answer for number 1 is the ordered pair 1, negative 3. Remember, that means on a graph, the 2 lines would intersect at that specific point. Looking at number 2, again, it is set up for elimination, but we don't have any opposites. So I'm looking for numbers that are the same, and that happens to be my x's. They're both a 2. So I'm going to change the signs on the second equation. So that becomes a negative 2x, a positive 2y, and a negative 12. And now I'm able to add them together. So my x's cancel. 3y plus 2y, because now it's positive, so that makes 5y. 8 plus negative 12. That's going to be a negative 4. Divide by 5. Y equals negative 4/5. If you looked at changing that into a decimal, it was an ending decimal, negative 0.8. So you could have put it in as a decimal if you'd prefer that. Either way works. So now we need to plug this back in. I'm going to go for the top equation because everything is positive, and that's easier to work with. So we have 2x plus 3. I have a feeling most of you use the decimal, so I'm going to put in the negative 0.8. If you use the fraction, good for you. That's awesome. So I have 2x minus now 2.4. It's minus because 3 times negative 0.8 turned it into a negative. So now I'm going to add that to both sides. So I have 2x equals 10.4. Divide by 2. X equals 5.2. So my ordered pair for this one would be 5.2 and negative 0.8. Now think about that on a graph. Would you be able to specifically identify that point? The answer is no, you'd be estimating, which is why graphing is not always the best method, and we have methods like elimination and substitution to help us out with. We are working on 9.4 today, but we're going to jump all the way to page 305 to start. We're going to skip the Explore activity and go directly to the notes. So again, make sure you're on page 305. We're still working on elimination today, but elimination does not always start ready to go. All the ones we've seen, the most we had to do was change the signs of the bottom equation. But what happens if the numbers don't match up at the beginning? You know, instead of having opposites, the numbers are just different numbers. Well, that's what we work on when we call multiplying, elimination by multiplying. Just like this is saying here, Sometimes the variables cannot be eliminated by adding or subtracting. So we start with multiplying either one or both of the equations by a constant in order to add or subtract to eliminate. So your steps are as follows, and this follows for multiplying one equation or multiplying two. You're going to decide which variable to eliminate, and you might decide differently than your neighbor. You're then going to multiply one or both equations by a certain number in order to change them into equations that eliminate by adding or subtracting. And then you do exactly what we learned right before Thanksgiving and what we did on the warm-up. So if you look at the example they gave you, 3x plus 8y equals 7 and 2x minus 2y equals negative 10. Well, if you notice here, we don't want to graph these because again we try to avoid graphing. Substitution would be tough because none of the variables are by itself, so we'd be having to do some division, which sometimes gives us decimals and that's harder to work with. But if I try to add them together, the x's wouldn't cancel and neither would the y's. And changing the signs on one of the equations isn't going to make that happen either. So what we have to do is either make our x's turn into the same number or our y's. And again, you can choose either way. But if you notice, I can turn a 2 into an 8, which means I wouldn't have to multiply this equation, I would just have to multiply this one. The sign's already the opposite, so I don't even have to worry about that. So the question is, what would I multiply that 2y by to turn it into an 8y? And hopefully you answered, well, you'd be multiplying by 4. So if you look at their step 1, they took that equation, they just wrote it first here, and they multiplied it by 4. Now, in order to keep that equation balanced, you have to multiply everything by 4. And that's where they got the 8x minus 8y equals negative 40. They then brought down that top equation, 3x plus 8y equals 7, and now the y's can cancel, and then we add the other pieces. 8x plus 3x is 11x. Negative 40 plus 7 is negative 33. And then we solve for x by dividing both sides by 11. Just like every other problem, you have to have both x and y values. So we plug the x back in. You can choose either equation. This one, since the first equation is all positive, I would recommend doing that one, which is what they chose as well. And when they plugged it back in, they got an answer of 2. So the solution is negative 3, 2. We're going to practice one together here. With step 4, just like any other one, you can solve it also by graphing, so that's how they check their solution. Remember, you could also check your solution by plugging x and y back into both equations and make sure it becomes a true statement for both of them. Not just one, but for both. So here's one for us to do together. To solve this system by multiplying, we need to figure out which one we're going to eliminate. And again, if you can get away with just multiplying one equation by number, that would be even better. So I look at my x's. They're opposites, but the numbers can't turn into each other. I look at my y's. They're not opposites, but I could turn this y into a 4y by multiplying by 4. But that wouldn't cancel them out because they'd both be positive. So in order to do that, that means this time I have to multiply not just by a 4, but by a negative 4. So I'm going to rewrite the top equation. Negative 3x plus 4y equals 12. And I'm going to write the second equation after everything's been multiplied by negative 4. So negative 8x, no longer plus y, now it's minus 4y. And that negative 8 now becomes a positive 32. And now I have a pair of opposites that I can eliminate, so they're gone. Negative 3x plus negative 8x is negative 11x. 12 plus 32 is 44. Divide by negative 11. So x equals -4. Unfortunately, that's not enough of an answer for this problem, so now I need to go back to either equation to solve for y. Well, I'm going to go back to the one where y is easier to solve for, which is the bottom one, and I'm going to plug x in here. So I'm going to have 2 times x, but x is -4, plus y equals -8. 2 times -4 is -8. And now to solve for y, I need to add 8 to both sides, which means y equals 0. Remember, 0 is a perfectly acceptable answer. That does not mean we have a no solution or an infinitely many. 0 is a number. So my solution here is -4, 0. Now, what happens if multiplying just one of them doesn't cut it? It doesn't make them have a pair of opposites, which means you might have to multiply both. This is as hard as elimination gets, and students still usually find this pretty simple. It's kind of like finding your common denominators of a fraction. You want them to have the same number. The difference here is we also want the numbers to be opposites. So if we look at the example they gave us, obviously elimination would be the better method because we don't have a variable easy to solve for, and of course we're not going to graph it unless absolutely told to. Well, my x's won't currently eliminate, and I can't make a 4 into a 3 or a 3 into a 4 by multiplying. My y's won't eliminate, and I can't turn a 9 into a 13 or a 13 into a 9 by multiplying. So I'm going to have to multiply both. Now, you could either multiply both to make the x's eliminate or multiply both to make the y's eliminate. But if I try to make the y's eliminate, I'm going to have some big numbers. However, I can turn a 3 and a 4 into both a 12 very easily, which would make them eliminate. So in order to do that, to turn a -3 into that -12, I'd have to multiply by 4. And to turn a 4x into a 12, I'd have to multiply by 3. Well, they're already opposites, which is good, so that means I don't have to worry about multiplying by a negative number. So if you look at what they did, here's the multiplying by 4 and the multiplying by 3. So when I multiply that first equation by 4, I get -12x plus 36y equals -12. When I multiply the bottom equation by 3, I get a positive 12x, -39y, and a positive 15. So now I can add these together. The x's will cancel out. 36y and -39y is the -3. -12 plus 15 is a positive 3. That's the 3 that's hiding out down here. To solve for y, we divide both by -3, so y equals -1. Just like every other problem, once you find one of the variables, you still have to find the other. So in step 2, they chose to find x by plugging it into the second equation, and they got x equals -2. So the solution is -2, -1. You can check that by plugging both -2 and -1 in for x and y for each equation, or as the book showed you earlier, you could also graph it to check it. So now here we have 2 problems to do. We're going to do number 4 together and leave you to do number 5. So number 4, I can either make my x's match or my y's. Either way doesn't matter. It's up to which one you find easier. 5 and 2 would be pretty easy to make the same number because I can turn them both into a 10, but they're both positive, so that wouldn't be opposites. However, the 3y and the -2y are already opposites, and it'd be pretty easy to turn them both into a 6. So I'm going to multiply the top one by 2. and I'm going to multiply the bottom one by 3. So when I multiply that top one by 2, I have 4x plus 6y equals negative 2. The bottom equation, when I multiply it by 3, I'm going to have 15x minus 6y equals negative 36. So now that I have opposites, I can add them together. 4x plus 15x is 19x. My y's eliminate. Negative 2 and negative 36 is negative 38. Divide by 19 to solve for x. So x equals negative 2. That's not good enough answer because if I have x, I also need to find y. So I look at both equations to figure out which one would be easier, and I'm going to choose the top one because there's more positives. So I'm going to go 2x, but x is negative 2, plus 3y equals negative 1. 2 times negative 2 is negative 4. So now to solve for y, I'm going to add 4. 3y equals 3. Divide both sides by 3. Y equals 1, which means my answer is negative 2 comma 1. So now I want you to do number 5 on your own. Check with the neighbor. Remember, you actually could approach this problem 2 different ways and still get the same answer, and I'm going to show you both ways when we go over this. So go ahead and work on number 5. Unpause this when you're ready to move on. The most logical way for you to solve this problem would be to eliminate your y's. And the reason for that is 1, they're already set up with a plus and a minus, and 2 and 5 is pretty easy to turn into, hopefully you turn them into a 10. So I'm going to start the problem that way, and then I'm also going to show you how you could eliminate the x's as well. So to eliminate your y's, I'm going to multiply the top equation by 5, and then you should have multiplied the bottom equation by 2. So your top equation should have turned into 25x minus 10y equals 55. And your bottom equation should have turned into 6x plus 10y equals 38. Add them together. Y's cancel. 25x plus 6x is 31x. 55 plus 38 turns into 93. To solve for x, divide by 31. Your x should have equaled 3. You then should have put that back into either equation for x or y. I'm going to recommend the bottom one since it's all positive. If you didn't choose the bottom one, that's fine. So 3 times x, which means 3 times 3, plus 5y equals 19. 3 times 3 turns into a 9. Subtract 9. 5y equals 10. Divide by 5. Y equals 2. So your solution would have been 3, 2. Now, if you need to look at any of this work, pause it right now because I'm going to move the screen so I can show you how you could have eliminated your x's instead of your y's. So again, the work is going to disappear, so pause it right now if you need to. So again, there's two ways to always do an elimination problem. So this time, instead of making my y's match, I'm going to make my x's match. Well, 5 and 3, I need to turn them into a 15, but one of them has to turn into a 15x. So you could either multiply the top one by negative or the bottom by negative. I'm going to choose the bottom one. So the top one, I'm going to multiply by 3, and then the bottom one, I'll multiply by negative 5. So if we multiply the top equation by 3, we get 15x minus 6y equals 33. And then multiplying the bottom equation by negative 5, because again, since these were the same signs, you had to make one of them multiplied by negative. So now we get negative 15x. That positive 5y turns into a negative 25y. And 19 times negative 5 equals a negative 95. Now that we have the pair of opposites, the x's will eliminate. Negative 6 and negative 25y makes negative 31y. And negative 95 plus 33 is a negative 62. So when we divide by negative 31 here, our y value equals a positive 2. Plugging that back in would also give us the x value of 3. But again, that's why there's going to be multiple ways that you can solve by elimination and still get the right answer. Now, just like the other sections, we also have word problems with these. So looking at the example they gave us, Jessica's buying 13 flowers, and she's buying daisies and tulips. So we know that between the daisies and tulips, they have to add up to 13. So there's your first equation, d plus t equals 13. The second equation is how much they're worth, their cost. Daisies are $1.25, tulips are 90 cents, and she has $14.85 to spend on it. With these, when you are going to be multiplying to eliminate them, you will technically be multiplying by some decimals. So feel free to use your calculators to go through these. And as you look through their work, you'll notice that they multiplied the first equation by a negative 0.9. So then they did what we've done in the previous problems. They substituted in the 9 daisies, and that meant that they had 4 tulips. And again, you can double check that 9 plus 4 is 13, and then if you plugged them into the second equation, you would see they also equaled the same amount. We're going to do one more together here. So our problem here is where we have roses and lilies. We have the cost of roses and lilies, and then the fact that she spent $24.75 on 12 flowers. Well, the first thing is that 12. So we know that the roses plus the lilies has to equal 12. So there's your first equation, kind of like how many. Your second equation is then their worth. Well, roses are worth $2.50. Lilies are worth $1.75, and that total has to be $24.75. Well, in order to solve this, we need to multiply to make a pair of opposites. So you can either multiply the roses or the lilies. I'm going to go ahead and multiply the roses to make them match. So times $2.50. But because they're both positive, I need to multiply it by negative 250. So I'm going to write that one right below. So r times negative 250 is negative 250r. The L turns into negative 2.50L. And you could also use 2.5. And then you've got 12 times negative 250. Which is negative 30. Now that we have a pair of opposites, we can add these together. Roses eliminate. 1.75 minus 2.5 is negative 0.75 L. And then the 24.75 added to a negative 30 is negative 5.25. Divide both sides by negative 0.75. And Lily's equals 7. Now you could plug it into either equation. Hopefully you recognize the top one is the easier one. So R plus 7 for Lily's equals 12, which means you have 5 roses. And there's your 2 answers. Tonight you've got a few problems on these, and then tomorrow you're going to practice in class as well to make sure you have elimination by multiplication down pat.